So hello students, welcome to Saurabh's classes. So today we are going to solve the questions of bmath 2021. Okay, so bmath 2021. Okay, so the question number 30 says that if such R2R be a function defined by fx is equal to 1 minus cos x into sine 1 by x. So I'm writing this fx. Just a second. So fx is equal to fx is equal to 1 minus cos x into sine 1 by x. So I am writing this 1 minus cos x into sine 1 by x when x not equal to 0 and 0 when x equal to 0. Okay students, so the option says that option A says that f is discontinuous, option B says that f is continuous but not differentiable, option C says that f is differentiable and its derivative is discontinuous, option D says that f is differentiable and its derivative is continuous. So we have to find out the correct option. So first of all, observe that when x not equal to 0, fx is continuous. So we need to check the continuity of f for x equal to 0. For this, what I am going to do, I am going to find out the limit x tends to 0 fx. Okay, so when x is approaching to 0, then x is not equal to 0, and then I can say this is limit x tends to 0 fx is 1 minus cos x into sine 1 by x. Now you can see that if you are putting x equal to 0, so that would be 1 minus 1 is equal to 0, and sine x is bounded quantity, so this is nothing but 0. That is equal to f of 0, and hence I can say that this function is continuous, so I can discard option A. Okay, so f is continuous, so option B says that f is continuous, option C says that f is differentiable, option D says that f is differentiable but its derivative is continuous. So now we need to check the differentiability of f. Now you can see that when x not equal to 0, f must be differentiable, so we need to check the differentiability of x at x equal to 0. So for this, so we need to check the differentiability of it at x equal to 0. We are just limit h tends to 0 f of 0 plus h minus f of 0 by h. So that would be limit h tends to 0 f of h minus f of 0 by h. So that would be limit h tends to 0 f of h is equal to 1 minus cos h by that is equal to second that is 1 minus cos h into sine 1 by h, right? So this limit is equal to, so now we need to talk about the existence of this limit, right? So for this, what I am going to do, I am going to write limit h tends to 0. Okay, 1 minus cos h, I can write it 2 sine square h by 2 by h. Okay, 2 sine square h by 2 into h into sine 1 by h, right? So I can write it or in other word, I actually can, what I can do, I can do it. I can write it limit h tends to 0 2 into sine squared h by 2 by h square by h by 2 is whole square, right? So I need to multiply by 4 and h. Okay, so h balance and 2 4, so into sine 1 by h, right? So what I can do, I can write this limit h tends to 0, 2 into sine h by 2 by h by 2 its whole square into limit h tends to 0 h by 4 into sine 1 by h. Now this limit is 2 into 1 into this limit is as h tends to 0, 0 sine 1 by h is bounded, so I can write this 0, so that limit would be 0, and hence I can, this limit is 0, so finite and this limit do exist, hence I can say that this function is differentiable. So now I can discard the option B. Now there are two possibilities. The first option says that option C says that it is that the derivative is discontinuous. The first option says that the derivative is continuous. Okay, so for this, what I am going to do, first of all, I am going to erase it. So we already got f dash 0 is equal to 0. Now I need to, when x not equal to 0, I need to find the derivative of it. For this, f dash x. So we need to use the UV derivation. We need to use the UV derivation. So that would be derivative of cos x is minus sin x. So minus of minus. So that is minus sin x into sin 1 by x. Okay. Plus when then I need to differentiate this. So 1 minus cos x into derivative of sin x is cos 1 by x into 1 by x. So the derivative of 1 by x, so that would be minus 1 by x square. So f dash x is equal to sin x sin 1 by x plus minus 1 by x square 1 minus cos x into sin 1 by x, right students? So now so this is our f dash x. Now we need to check whether limit x tends to limit x tends to 0. So just a second, I am removing all of this. Now we need to check whether the derivative of f is continuous or not. For this, you can see when x not equal to 0, then f dash x must be continuous. So we need to check the derivative continuity of f dash x at x equal to 0. For this, we need to check whether limit x tends to 0 f dash x do exist or not. For this, I am starting with limit x tends to 0. The derivative of x sin 1 by x minus 1 minus cos x by x square into sin 1 by x. Now observe that this limit do exist. When you are calculating this limit, so that would be 1 minus cos x would be sin squared x by 2 and by x square, so we can balance it, but so this limit do exist, but sin 1 by x does not exist, so this limit does not exist. Okay, are you getting my point? So this limit does not exist, and hence I can say that option C, that is f is differentiable but derivative is discontinuous at x equal to 0, is our correct option. Okay students, so we have solved the question number 30. Okay.